So we are continuing our video. The problem that we are looking to solve is we are continuing solving the problems. Write the formula. Write the formula for the ionic compound. Derived from the following ions. So we are just continuing with that. So here we have calcium and bromide. So if you look at the ions themselves, calcium, the symbol is Ca. Bromide, the symbol is Br. Group calcium is in group 2, bromide is in group 7. So because calcium, that is 7A. So because calcium is in group 2, therefore the ion is Ca2+. Bromide ion is in group 7, so the ion will be Br -1. So you put these two together, Ca2+, Br negative. So you do the crossing, you take the 1 here and put it down here. You take the 2 here and put it down here. So your compound will be CaBr2. So that is our ionic compound. Let's look at another compound. Barium and sulfide. So the barium, the symbol is Ba. The sulfide, the symbol is S from sulfur. This is in group 2. This one is in group 6. So because of that, the ion formed from barium will be Ba2+. The ion formed from the sulfide will be 2S2-. Now if you bring them together, 2+, S2-, they give you the compound BAS, because the charges have already cancelled each other. Now let's look at another problem. So the question is still, what is the formula for the compound derived from, here we have iron 2 and sulfide. So if you see iron 2 written, just know that iron 2 is Fe2+. The 2 here is standing for 2+. Sulfide, from our previous, we know that sulfur in group is in group 6. So sulfide will be S2-. So if you bring them together, Fe2+, S2-. So the charges have already cancelled because this is 2, this is also 2. So our compound is FeS. Let's look at another problem. So we have iron 3 and oxide. So iron 3 means that we have Fe3+. Because of the 3 here, it's indicating the charge is 3+. Oxygen is in group 6. Group 6A. So this one is also group 6A. So oxygen is in group 6A. Therefore, the charge is -2. So the oxide here is O2-. So remember, we want to write a formula for a compound derived from Fe3+ and O2-. So you bring together the ions like I'm doing here, and then the next thing you do, you need to cross them. Take this 2 and put it down here. Take this 3 and put it down here. So in the end, what you have is Fe2, then O3. So that is iron 3 oxide. Let's keep on. What about this question? It's similar to the question we have dealt with before. Let me get rid of this. So write the formula unit for the following. All right. So here we have chromium 3 and oxide. So the chromium 3, the symbol for chromium is Cr. The 3 here tells us that it is chromium 3+. The oxide, we know oxygen is in group 7, therefore the oxide will be or 2 minus. So you bring them together, 3 plus or 2 minus. You just take this one and put it there, and take this one and put it here. So you are going to get Cr2O3. That is chromium 3 oxide. Let's see another. Cobalt 2 and nitride. So here the symbol for cobalt is CO. The 2 tells us that we have CO2 plus. So this is the charge. The nitride is coming from nitrogen. So nitrogen is group 5. Therefore, the charge is -3. So here we are going to have N3 negative. So if you bring them close together, you have CO2 plus and N3 negative. Just transfer this 3 to here, then transfer the 2 to here. So you are going to have CO3 and N2. So let's go on and solve another problem. Platinum platinum 4 and sulfide. So platinum, the symbol for platinum is PT. So the 4 here shows us that it is PT4 plus. And the sulfide, because sulfur is in group 6A, so the sulfide is supposed to be S2 minus. So here we put them together, PT4 plus S2 minus. Now what you want to do is you transfer this one to here and also transfer this one to here. So you are going to have PT2 S4. But then after that 2 goes into both of them. So you want to divide this one by 2 and also this one by 2. So this one becomes 1, this one becomes 2. So in the end, you are going to have PT and S2. So let me just write it properly so that it looks good. So you have PT S2. But we are saying that if you cross this one, initially it will give you PT 2 S4. And then after that you have to cancel, because here 2 goes into here and also 2 goes into there to give you PT S2. So really, that's how we solve these problems. Now let's go to the next problem. The next problem is so write the formula unit for sodium phosphate. So really what you need to do is you just need to go on the periodic table and find out what sodium is. So the ion for sodium is Na plus. For phosphate, you have a table that has that information, but the ion is PO4 3 minus. Now you want to determine the formula unit for this. What you want to do is put these ones together. So I'll put Na plus here and PO4, then in parentheses, then 3 minus. So after that, you take this 3 and put it below here, and the 1 you put it here. So you are going to have Na3 PO4 1. But when you have 1 here, you remove the parentheses. So you are going to have, in the end, what you are having is Na3 then PO4. That is sodium phosphate. What about another ion? Formula unit for sodium hydrogen phosphate. So you have 2 ions there. First you have sodium, and then you have hydrogen phosphate. So we know that sodium is always Na plus. The hydrogen phosphate, from the table, it is HPO4 then 2 minus. That is the hydrogen phosphate. So what you are going to do is to bring together these 2 ions. So you have sodium here, and then you have HPO4. Remember to put the charge outside. After that, you take the 2 and put it down here. You take the 1 and put it down here. Since you have 1 here, there is no need for this parentheses. So you are going to have Na2HPO4. That is sodium hydrogen phosphate. Let's look at another formula. What about magnesium hydroxide? So here magnesium is in group 2. So since magnesium is in group 2, we are going to have Mg2+. The hydroxide, we know from our table, the hydroxide is OH minus. So what you want to do is to bring this together, Mg2+, and don't forget to put this one in parentheses, minus. So we take 1 from here and put it there, and we take this 2 from here and put it here. Since this one will have a 2, we need to keep the parentheses. So you are going to have MgOH2. That is magnesium hydroxide. Another example, let's look at formula unit for aluminum carbonate. So aluminum is in group 3A. So being group 3A, we are going to have Al3+. And the carbonate is CO3 2-. So these are the things that you need to know what these ions are. So then you bring them together. So you are going to have Al3+, here CO3, then 2-. So you transfer this 2 down here, then you transfer this one down here. In the end, you are going to have aluminum 2, then in parentheses CO3 3. That is aluminum carbonate. So really that's how we determine the formula for a carbonate. Now, another thing that you talk about is naming ionic compounds. So say name the following ions. So Let me start with MgCl2. So the metal, you just give it the name of the metal. So I'll start with binary compounds. You need to know the definition of binary compounds. So binary compounds contain two ions. Contains only two, not just two ions, but contain two types of ions. So two types, not ions, but elements. Binary compounds contain two types of elements, and these binary compounds, they don't have extra oxygen. So if you look at MgCl2, it's a binary compound. It does not have that extra oxygen. So when naming binary compounds, you just name the metal as it is, magnesium, and this is chlorine. You remove the last part of chlorine and add Id. So this one will become magnesium chloride. So another ion, Al2O3. This is also a binary compound because it has aluminum and oxygen only. So those are two elements. So I'll name the metal as aluminum, and then the oxygen here becomes oxide. Then I have, if you look at these, if you look at aluminum and magnesium, you see that magnesium is in group 2A, aluminum is in group 3A. Let's look at another metal. Na2S. So this metal, the metal here is sodium, and the non-metal is sulfide. So sodium sulfide. So the statement here, ions made of metals from groups 1A, 2A, and 3A, right, do not need Roman numeral names. But if you have metals that are not made from these, you can see here magnesium is from group 2A, aluminum is from group 3A. Sodium is from group 1A. That's why I didn't put any Roman numerals in between them. But let's see names. Ionic compounds with Roman numerals. For example, the following ion, Fe, the following ionic compound, FeCl2. So we want, actually I want Cl3 here. So we want to name the compound. So the first thing you know is that ion is not. So Fe is not in group 1A, 2A, and 3A. And because of that, it will need a Roman numeral to name it. So how do you deal with that? So what you do, you have Fe here, Cl3. You need to find what Roman numeral to put here. That's what we do. What Roman numeral are we going to put on this one? So to find that, we know that Cl is in group 7. Therefore, Cl is a negative. So a Cl has a charge of -1. So if you put, we have 3 of them here. So you say 3 times the charge of -1. We get -3, which means 3 chlorines here will give you -3. As a result, you are going to have Fe and then Cl3 here, -3. Since you have -3 here, this one must have -3. So what you are saying here, the Fe should be given as -3. And this kind of Fe is known as ion 3. So the compound itself will be ion 3 chloride. That's what the compound will be. You need to make sure that if it's not in group 1A, group 2A, group 3A, you need to find the number that you want to put there. Let's look at another ion. So name the following: SnCl4. So as usual, Cl is in group 7. And because of that, the Cl will be Cl minus. But here, we have 4 of them. So it will be 4 times minus on the part of the Cl. So we are going to have SnCl4. The charge for all of them is -4. So let me put -4 there. So the charge for all of them is negative. For all these chlorines is -4. So to cancel this, you need plus 4 here. So what we are saying is the tin is tin 4 plus, which is known as tin Roman numeral 4. So in general, the name of the compound will be tin 4 chloride. Now let's name another compound. So name PbO2. So for this compound, we know that O is in group 6. Therefore, O will be 2 minus. So we are going to write this one O2. But you see there are 2 oxygens here. So we need to multiply 2 times -2, because each oxygen here has a charge of -2. So this will give you PbO2, but the total charge is -4. That is the total charge of oxygen. Now, if the total charge of oxygen is -4, then this one must be +4. So +4 means you have Pb4 plus, which is lead numeral 14. So the whole ion is lead 4 oxide. So that's how we name these ions. Let me see if we have to name something else. So let's name I think for now let us stop here, and we'll continue with another video later.